from a single point, smaller than an atom, containing everything. Then, in an instant, an explosion of unimaginable scale. 13.8 billion years ago, our universe was born. This is the story of everything. In the first fractions of a second, the universe expanded faster than the speed of light, a process we call cosmic inflation. It was a searingly hot, dense soup of fundamental particles, quarks, electrons, photons zipping around in a chaotic dance. As this primordial universe expanded, it began to cool. Just a few minutes after the Big Bang, conditions were right for the first atomic nuclei to form. Protons and neutrons fused together to create the lightest elements, mostly hydrogen and helium, with a tiny bit of lithium. For about 380,000 years, the universe was still an opaque, glowing fog. Light couldn't travel far without bouncing off free-roaming electrons. But then, as it cooled further, electrons were captured by atomic nuclei, forming the first stable atoms. Suddenly, the universe became transparent. The light from that moment, the cosmic microwave background radiation, is something we can still detect. Today it's the oldest light in the cosmos, a baby picture of our universe. After this first light, the universe entered what's known as the cosmic dark ages. There were no stars, no galaxies, just vast clouds of hydrogen and helium gas drifting through the darkness. But this wasn't an empty, static void. Tiny fluctuations in the density of this gas, minuscule variations from one spot to another, were the seeds of everything that would come. Gravity, the quiet, persistent architect of the cosmos, began its work. It started pulling these denser regions of gas together. Slowly, over millions of years, these clouds grew larger and denser. The pressure and temperature at their cores began to climb. About 200 million years after the Big Bang, the first stars ignited. These were not like our sun. They were cosmic behemoths, hundreds of times more massive, burning incredibly hot and bright, living fast and dying young. They blazed for only a few million years before exploding in spectacular supernova. These explosions were crucial. They forged heavier elements inside their fiery cores: carbon, oxygen, iron, all the elements essential for life on, then scattered them across the cosmos. These enriched clouds of gas and dust then collapsed to form the next generation of stars and, for the first time, galaxies. Gravity pulled these early stars together into sprawling collections, spinning and merging to create the beautiful spiral and elliptical galaxies we see today, including our own Milky Way. Fast forward several billion years, within one of the spiral arms of the Milky Way, a new story was beginning. Around 4.6 billion years ago, a vast cloud of interstellar gas and dust, enriched by generations of long-dead stars, began to collapse under its own gravity. Most of this material spiraled into the center, becoming hotter and denser, until nuclear fusion ignited. Our sun was born. The remaining material flattened into a spinning protoplanetary disk around the newborn star. Within this disk, dust grains stuck together, forming pebbles, then boulders, then planet. Through countless collisions and mergers, these planetesimals grew into the planets we know today. Closer to the sun, where it was warmer, rocky planets formed: Mercury, Venus, Earth, and Mars. Further out, in the colder regions, gas and ice giants took shape: Jupiter, Saturn, Uranus, and Neptune. The early solar system was a violent, chaotic place. For hundreds of millions of years, the inner planets were subjected to the late heavy bombardment. A storm of asteroids and comets, left over from planet formation, rained down, pockmarking surfaces and delivering crucial ingredients, like water and organic molecules, to the young Earth. It was a period of destruction, but also creation. On our own planet, something extraordinary was about to happen. Around 4 billion years ago, in the warm, chemical-rich oceans, the first sparks of life emerged. We still don't know exactly how it happened, but simple organic molecules organized themselves into self-replicating structures. The first life was likely single-celled organisms, simple microbes thriving in an alien world. For billions of years, these tiny life forms were the sole inhabitants of Earth, slowly transforming its atmosphere by releasing oxygen as a byproduct of photosynthesis. This great oxidation event was catastrophic for the early anaerobic life, but it paved the way for more complex, oxygen-breathing organisms to evolve. The pace of evolution picked up about 540 million years ago. The Cambrian explosion saw a dramatic diversification of life, with the ancestors of most modern animal groups appearing in the fossil record. Life colonized the land. Plants grew, forests spread, and insects took to the air. Then came the age of reptiles. For over 150 million years, dinosaurs dominated the planet. They were the undisputed kings until about 66 million years ago, when another cosmic collision changed everything. An asteroid, about 6 miles wide, slammed into the Yucatan Peninsula, triggering a mass extinction that wiped out the dinosaurs and about 75% of all species on Earth. But this catastrophe opened a new door. With the great reptiles gone, a small, shrew-like group of animals that had been living in the shadows finally had its chance. Mammals. They diversified rapidly, filling the empty ecological niches. Over tens of millions of years, they grew larger, smarter, and more varied. Primates evolved, and from one branch of that primate family tree, our own ancestors emerged. The journey from early hominins to modern humans is a story of adaptation, innovation, and migration, a tiny blip in the vast timeline of the cosmos. But for us, it's everything. So, where is all this heading? The story of the universe is far from over. Right now, we live in a dynamic, evolving cosmos. One of the most surprising discoveries of the 20th century was that not only is the universe expanding, but its expansion is accelerating. A mysterious force, which we've named dark energy, seems to be pushing everything apart, counteracting gravity on the largest scales. This acceleration holds the key to the universe's ultimate fate. One leading theory is the heat death or the Big Freeze. If the expansion continues to accelerate, galaxies will eventually be pushed so far apart that they will disappear over each other's cosmic horizons. The sky will go dark. Stars within the remaining galaxies will burn out, one by one. Black holes will eventually dominate, slowly irradiating their energy away through Hawking radiation over trillions upon trillions of years. Eventually, even they will evaporate, leaving a cold, dark, and empty universe filled with a sparse soup of leftover particles, approaching a state of maximum entropy from which nothing new can ever happen. It's a somber, lonely end. But there are other possibilities. What if dark energy isn't constant? What if it weakens, or even reverses? Then gravity could regain the upper hand. The expansion could slow, halt, and reverse. The universe would begin to contract, leading to a big crunch. Galaxies would rush back together, the temperature would rise, and everything would ultimately collapse back into the same singularity from which it all began. Some theories even suggest this could lead to a cyclical universe, a big bounce, where each big crunch seeds a new big bang, creating an endless cycle of cosmic death and rebirth. Right now, we don't know which fate awaits us. Our observations favor the Big Freeze, but our understanding of dark energy is still in its infancy. The universe is full of mysteries yet to be solved. We are a curious species on a small planet, looking out at the vastness and trying to piece together the grand narrative of our existence. From a single point to this very moment, it's been a spectacular journey. And as we continue to explore the cosmos, who knows what other incredible stories we will uncover. Thanks for watching this journey through time. If you enjoyed exploring the universe with us, don't forget to like, subscribe, and hit that notification bell for more cosmic adventure.